is 8.3, day 1. The topic today is multiplying and dividing rational expressions. Don't need to write the objective down. We're going to simplify rational expressions, explain what rational expressions are, and then go on to multiplying and dividing rational expressions. First line, don't write it down. This is the definition of a rational expression. It's a quotient of two algebraic expressions. So we have some examples here. 1 over x, or 2x minus 1 over x plus 1, or x squared plus 1 over x squared minus 1. When you hear rational, think of quotient or fraction. All right, here are some rules for you. You don't need to write them down. You'll get enough practice with these problems in the next 2 days, this lesson set and then tomorrow's lesson set. Here are the rules for multiplying and dividing. If you have division, you want to change it to multiplication, that division, and then reciprocate. Number 2 is to factor everything possible. So again, factoring is coming back in this chapter. After that, we cancel any like factors and then clean up your answer. All right, let's go through these problems. Simplify the following rational expressions. Divide out any common factors. So I'm going to just review a little bit backwards from here where we think about pre-algebra and algebra 1 when we reduce fractions down. So question A. 15 over 27. Think back to what we did to reduce those. We want to find a common factor. So 15 over 27. What are both of those numbers divisible by? And you want to find the greatest factor. So we can divide 15 by 3, and we get 5. We can divide 27 by 3, and we get 9. So our final answer then is 5 9ths. Let's go down to reviewing multiplication of fractions. When you multiply fractions, we want to reduce first before we multiply across. So we look at this example, 6/25 times 5 9ths. We look and see if there's anything in the numerator can cancel with the denominator. So I'm just going to write the fraction set again so you can remember the original. So 6 over 25 times 5 9ths. Well, 25 and 5 have a factor of 5. So 25 divided by 5 is 5. 5 divided by 5 is 1. And then 6 and 9 can both divide by 3. So this becomes 2, this becomes 3. Now I'm just going to rewrite what we have. 2 over 5, 1 over 3. You don't have to do that step, but sometimes this is nice, you don't get anything to be lost. Now the rule is when you multiply fractions, you multiply across. You multiply the numerators together and the denominators together. So 2 times 1 is 2. 5 times 3 is 15. And there is our answer. All right. Now we're going to go ahead and step it up. We're going to start adding in some variables. So question C. 15x squared times y cubed over 10xy squared. So I'm just going to rewrite this problem. I like to do that. So when I cancel, it's not so messy. So let's talk about the coefficients first. 15 and 10. I can reduce both of those by 5, a factor of 5. So 15 divided by 5 is 3. 10 divided by 5 is 2. Now I look for the variables. I have 2 x's on the top, and I have 1 on the bottom. So what I can cancel out is one of the x's. So this one of those x's is gone, so now I just have an x, and then x divided by x is just the number 1. Or you can just cancel it out. It's not 0 though. Now we have 3 y's in the numerator, and we have 2 y's in the denominator. The greatest we can take out of there is 2 y's. So when I take 2 of those y's out, I'm left with a y. I take those 2 y's out, I'm left with a y. I'm just going to go ahead and rewrite what we have. 3 times x times y over 2 times 1 times 1. You don't need to do that middle step I just did if you don't want to. So we have 3xy over 2 times 1 times 1, 2. All right. Question D is a little bit more challenging. Now we're going to have to start factoring. So remembering those rules of factoring. X squared minus 25 is in the numerator, and then 5 minus x is in the denominator. So the numerator, I can factor that as the difference of 2 squareds. So that would look like x minus 5, x plus 5. And what I want to have is maybe something in the denominator that cancels. When my denominator looks pretty close, I'm going to interchange those terms and make it negative x first and then positive 5 second. So I just flip-flop the terms in the denominator. I'm close, I want to make that positive x and a negative 5. So I'm going to remove a negative from this denominator. So the numerator still is the same, x minus 5, x plus 5. And I'm going to divide out a negative 1. So I'm left with x minus 5. So now we look and see what are some common factors in the numerator and denominator. Well, x minus 5 cancels, and x minus 5 cancels. So I'm left with x plus 5 over negative 1. I can bring that negative 1 up to the top, so it looks more like this. All right, question E of reducing a rational expression. A little bit more challenging now. We have a trinomial dividing a trinomial. And we want to make this factored. So we have to remember our rules of factoring. Our x squared, I'm going to stick this off to the side, minus 7x plus 12. Let's factor that first. Well, the leading coefficient is 1. So the method that we learned is the T-chart method. What are the factors of C, which is 12, that add to B, negative 7? Well, that is negative 3 times negative 4 multiplies to 12 and adds to negative 7. So these are the numbers we're going to work with. So up in the numerator, I split up my x's, because x times x would give us back to x squared, and then it's minus 3 minus 4. Now let's go to the denominator, that polynomial. We have x squared plus 3x minus 18. Again, leading coefficient is 1, so we're going to use the T-chart method. What are the factors of C that add to B? It's positive 6, negative 3. Add them together, and we get 3. So those are the numbers we're going to work with. So I split it up, x, x, and then plus 6 minus 3. Now look at those parentheses. Is there anything in the numerator that can cancel with the denominator? Is there a common factor? Yes. X minus 3 and x minus 3 will cancel. So we are left with x minus 4 over x plus 6. I'm going to stop recording there, and we'll pick up on the next one.